All right, here are some highlighted notes for day 8 as we go to chapter 3. All right, I know we're going out of order in the book, but we thought going in this order of the chapters would be most beneficial for you guys. All right, so in chapter 3, we're going to look at parallel lines, okay, skew lines, and parallel planes. Please read over these definitions. All right, hopefully we know what parallel lines are. Okay. And here I put this on here because of the way that we drew with the green ink. It's easier to see this diagonal plane. Okay. So hopefully, you can see that and it clarifies a little bit more. And then go over the answer key here. Okay, these answers. All right. All right, we're going to go over some key types of angles that are going to keep coming up. Key phrases and vocabulary words of different kinds of angles that you're going to need in this class and also possibly in Algebra 2 and also in Pre-Calc. All right. A transversal is a line that intersects two coplanar lines at distinct points. All right, so here in this diagram, line T is the transversal. You have what's called alternate interior angles, okay? And take a look at the pairing, right? Angle 4 and 6 are alternate interior angles, right? They're on opposite sides of the transversal, and it's interior because it's in between these two lines, L and M, right? You see the word here, interior, right? Angles 3, 4, 5, 6 are interior, and angles 1, 2, 7, 8 are on the exterior, okay? 3 and 5 are also another pair of alternate interior angles. And then you have alternate exterior, angles 1 and 7 and 2 and 8, again, opposite side of the transversal. Using the same diagram, a little bit smaller here, you have the same side interior angles, so 3 and 6, and 4 and 5, and same side exterior, 2 and 7, 1 and 8, okay? And then you have what's called corresponding angles, okay? They're on the same side of the transversal and in corresponding positions, okay? So what I like to think of it is, look at angles 1, 2, 3, 4, and angles 5, 6, 7, 8. And the key word that I like to think about is location, okay? Now, angles 1, 2, 3, 4, and then, they're not going to be congruent, and that's fine. But if you look at angles 1, 2, 3, 4, angle 1 out of the 4, right? Angle 1 is in the top left angle. It's the top left position. Down here, out of 5, 6, 7, 8, which one is the top left angle? Angle 5. So these are your corresponding angles. 2 corresponds to 6, 3 corresponds to 7, and 4 corresponds to 8. Okay? These are going to be pretty important to know. Okay? And then you have identifying angle pairs, right? A lot of this is kind of visual, right? That's why we try to use these different color markers and inks, right? Notice here, each blue line is the transversal, okay? And the highlighted are the answers to these, like in 11, right? Alternate interior angles, 1 and 4, right? 1 and 4, 2 and 3. Remember, either side of the transversal line, okay? And so take a look at, these notes and these solutions here. I think it'll be really helpful for you, okay? All right, and then here, we're going into 3.2, and if you look at the notes for 3.2, there's like a Desmos activity, but we're not going to do that, and so we're just going to highlight a few things here in 3.2, all right? Just going through a couple of these proofs, okay? Given that line L is congruent to line M, okay? All right. One thing to mention, all right, is that when you have these parallel lines, there are different relationships that we talked about. Okay, let me backtrack here a little bit. For parallel lines, alternate interior angles are congruent, alternate exterior angles are congruent, and corresponding angles are congruent. Same side interior and exterior angles, they are supplementary. Okay, but that's only if lines are parallel. Okay, and so going back to this proof here, you're given the fact that lines L and M are parallel, which means this third line is the transversal, which means 2 and 6 are corresponding angles because of location, right? And corresponding angles are congruent, okay? All right, so that's all you need here, right? You have your statement, angle 2 is congruent to angle 6, because if parallel lines, then corresponding angles are congruent, okay? Here in this example, for this proof, angles A and B are parallel, and prove that 1 and 3 are supplementary, right? So take a look at the logical thinking here. Angles 1 and 2 are congruent because if parallel lines, then alternate exterior angles are congruent. Angles 2 and 3 are a linear pair that's assumed from the diagram, right? Angles 2 and 3 are supplementary because if linear pair, then supplementary angles. Now notice you have to have statement 3, right? You can't just go to statement 4 and say this. You have to state and declare two angles are a linear pair, and then after that you can say that they're supplementary, because if linear pair, then supplementary angles, okay? Well, if they're supplementary, 1 and 3 are supplementary because of substitution property, right? If angle 1 is congruent to angle 2, and if 2 and 3 are supplementary, then that must mean that angle 1 is also supplementary to angle 3, okay? And this is not transitive property because remember when we talk about supplementary, it assumes measurement of 180, and when we talk about a numerical value, we use the substitution property and not transitive property. Here I just wanted to highlight a few important examples here, okay? So please take a look at these examples, all right? You know, you got to be able to distinguish what kind of angles you can use, right? So here, take a look at where I'm highlighting, right? These darkened arrows here indicate that they are parallel, kind of like how tick marks are congruent. These darkened arrows mean that they are parallel lines. And so here, this side AD acts as the transversal. Notice we extended it with a purple ink. And so therefore angle 2 and angle 50, same side interior, remember, are supplementary. So they add up to 180. Okay. Same thing over here. We have 3x plus 5 plus 2x plus 10. Because these are same side interior, they're going to equal 180 degrees, right? Right there. Okay, so just a few more examples. Okay, like that. All right, corresponding angles here in example 5a, right? More same side interior angles here. All right, and as we go to 3.3, just wanted to highlight a couple of proofs. Okay, prove that lines A and B are parallel. That's what you're trying to prove. Okay. Well, in order to do that, you have to show probably a relationship of these angles being congruent. Okay. You're given that these two diagonal lines are congruent, M and L. Okay. And line A is the transversal for M and L, and so therefore angle 1 is congruent to angle 3 in statement 2 because they are corresponding angles. All right. Angle 1 is congruent to angle 2 because it was given, right? And because of statements 2 and 3, that must mean that angle 3 is congruent to angle 2 by transitive property, not substitution, because we're not talking about any measurements, right? And so therefore, if 3 and 2 are congruent, now take a look, right? Angle 3 and angle 2 are alternate exterior angles, and we already showed that they are congruent, which must mean that lines A and B are parallel, which is what we're trying to prove, right? So they're parallel because alternate exterior angles makes these lines parallel. Again, just using these properties of angles and using some algebra work to solve for x here. Right, these are alternate interior angles, and so they're parallel. Right, it has to be given to you that they're parallel. If they're not, if it doesn't tell you that they're parallel, or if you look again here, these darkened arrows, right, then you cannot assume that they are congruent and equal in measure. Okay. And then here, just some practice, to make sure that these lines are parallel, right? 5 is supplementary to 9. Those are same side interior angles, so that must mean that line P is parallel to line Q. Okay, so take a look at these notes here. And I believe this is the beginning of the last file you should be looking at, called Triangle Proofs. And I wanted to highlight this because this idea of systems of equations is going to keep coming up, right? You got to have these setups to solve algebraically, right? And so you're going to use your knowledge of these angle relationships. So here, 2x plus 3y plus 3x plus 2y, that's a linear pair, so you set it equal to 180. Okay, looks like we combine like terms. But we also have 2x plus 3y, angle 1, is equal to 7y, which is angle 5, because these are corresponding angles. Right? Angle 1 corresponds to angle 5. And so here it looks like we set up the equation, we solve for x equals 2y. So then we use that to substitute into the other equation, because it's a system of equations, all right? So take a look at this example. And then a couple of proofs here to end with, okay? Example 4, you're trying to show that these two triangles are congruent, okay? So if you look through this proof, right, you're given that FG is parallel to KL. So FK is the transversal, okay? So that means GFK and LKF are congruent angles because of alternate interior angles, right? You're given that FG is congruent to KL. FK is congruent to itself, reflexive, and so you have a side angle side situation. Okay, so these two triangles are congruent. And then take a look at this proof as well. All right, there's a lot more involved here. Anytime you see perpendicular, you're going to have to declare right angles. Don't forget. Okay. And again, if you have right angles, then they are going to be congruent. So angle T is congruent to angle R. You're given that QT is parallel to RS, and notice these arrows, right? That's how we indicate they are parallel. And so we're going to use alternate interior angles and reflexive. And because you're trying to prove corresponding parts, after you prove the triangles are congruent, that's when you use CPCTC. All right? So hopefully this was helpful.